Okay guys, in this video I'm going to re-explain your periodic trends in case some people had issues with them. Alright, so what I'm going to do right now is really quickly re-explain the three different concepts that we went through. First of all, I'm going to talk about atomic radius. An atomic radius is basically how we measure the size of your atom. And specifically what we do, we take one atom, and since we don't know exactly where the last electron is, okay, we're going to measure the distance between two nuclei of two atoms, and then we're going to divide that distance by half in order to get this one distance. Alright, so we're going to take this distance right here, I'll highlight it. Okay. So distance between two nuclei. And then we're going to divide it by 2, and that is the atomic radius. Alright, so that's your atomic radius. The next concept we're going to go over is electronegativity, and we're going to relook at electronegativity when we're talking about bond polarity. But electronegativity is how strong an atom pulls its electrons, or specifically the extent or the attraction of an atom for its electrons. So the attraction an atom has for its electrons. And the last thing we're going to be talking about, the last concept, is ionization energy. Okay, and ionization energy is the energy required to remove an electron. So energy to remove an electron. Okay? And what we're going to do is we're going to use our periodic table right here in order to look at these three different characteristics and see how they change as we move across our periodic table. Okay? And down our periodic table. So as we move across our periodic table, I'm going to draw an arrow. Okay? That means we're moving across our period, because a period, remember, is your row. Okay. Let's look at what happens. Well, as I move across a period, yes, my number of electrons increases, and yes, when you move across a period and when you move down a group, your number of electrons will increase. Alright, but we're going to leave that alone because, for the moment, because yes, that does affect your size a little bit, but there are more important factors that will overrule that. Okay? And specifically, as you move across a period, what happens, if you notice, you have 19, 20, 21, 22, 23. Those are your atomic numbers, and your atomic numbers are your numbers of protons. So as you go across your period, you're actually increasing your number of protons. Okay? If you increase your number of protons, remember your protons are going to be attracting your electrons. So as you get more and more and more protons, they're going to be pulling in your electron cloud. Alright? So here's your electron cloud. And what's going to end up happening is it's going to be pulled in more and more and more as you increase your number of protons. So as I move across my period, my atomic radius is going to decrease as a result of the fact that I'm increasing my number of protons. Okay? Alright, let's look at what happens when I move down a group. Alrighty? Okay, let's look at it. Okay, well, as I move down a group, remember these numbers? Well, these numbers, 3, 4, 5, 6, all the way to 7, represent my number of principal energy levels. Okay? So if I have one principal energy level, that means I've just got one shell. Alright? If I have 7 principal energy levels, that means I have 7 shells. So I have 1, 2, 3, 4, and it's going to keep getting bigger and bigger and off my page. Alright, so what happens to my atomic radius as I move down a group is that it increases as a result of the fact that I'm increasing my number of principal energy levels. So atomic radius is going to increase. Alright, cool. Electronegativity, let's think about this. Attraction an atom has for its electrons. Alright, so think of, let's come up with the concept of magnets. So if you have a positive and a negative, I'm going to draw it down here. So here's one magnet, and here's my other magnet. Okay, and it's got, this one has the positive end, and this is the negative end. Now, if I'm talking about attraction, the attraction is going to be the greatest. Is it going to be the greatest when they're close together or when they're far apart? Okay, and I'm hoping you're saying when they're far apart, because if you think about it, with your experience with magnets, when you're holding them with your hands, right, and they're far apart from each other, you don't feel any sort of attraction. But when you bring them closer and closer together, it gets to the point where there's so much attraction that you can't keep them apart, and they're just going to snap together. All right. So as you notice, when the distance between your positive and your negative, or better said, your nucleus and your electrons decreases, that attraction is actually going to increase. Alright, and so what you should recognize is the fact that while atomic radius, when it decreases, your electronegativity is actually going to increase. Okay? And when one thing decreases, right, and the other thing is going to be increasing, that type of relationship is an inverse relationship. So as atomic radius goes down, your electronegativity is going to go up. Okay. Which means when your atomic radius, as you're moving down a group, increases, your electronegativity is going to decrease. Alright? Let's look at the last concept we talked about, which was ionization energy. That is the energy that you need to remove an electron. Well, if you have, let me redraw my atom. Okay, here's the top one's a small atom, here's a big atom. Now, I've got an electron here, I've got an electron here. Now, remember my center, the pink is showing the positive charge. Okay? My center is positively charged, while my electrons are negatively charged. So if they're really close together, the negative and the positive, that's going to require a lot of energy to remove that electron. Right? While here, because your electron's so far away, first of all, and don't forget, you've got other electrons that are going to be repelling this electron as well and interfering with this relationship. Okay? As you increase the size of your atomic radius, the energy required to remove that electron is going to decrease. It's going to be easier to do. Removing that's going to be real easy when it's this big versus when your electron's that close to your nucleus. Okay, so if you notice, when your atomic radius decreases, the energy required to remove an electron, or your ionization energy, also increases. So electronegativity and ionization energy are directly related, while they are inversely related to atomic radius. Okay? And ionization energy here, due to the fact that your atomic radius is increasing, your ionization energy as you move down a group is going to also decrease, just like your electronegativity. Right? So why do we care about these trends? Well, we want to compare specific elements and compare their electronegativity or their atomic radius or their ionization energy. In the unit that we're going to start in, Unit 6, we're going to be comparing electronegativity. So let's practice with that right now. Okay, so for example, if I say, okay, which one has a higher electronegativity? Let's say I give you sodium, Na, or sulfur. Okay. Well, what you should recognize is the fact that as you move across your period, right, your electronegativity increases. So if you're looking for the element that has a higher electronegativity, it makes sense that sulfur would have a higher electronegativity. And you're right, sulfur has a higher electronegativity than sodium. And you're done. So it's pretty nice and easy once you know the trend. All right, let's compare silicon, okay, and tin. Which has a higher electronegativity? Well, if you remember your trend, as you move down your group, your electronegativity decreases. So you want to be as high up as possible in order to have the highest electronegativity within that group. So silicon in this case will have a higher electronegativity than tin. Well, let's get to a slightly more challenging issue. What if I were to give you, for example, lithium, okay, and magnesium? Okay. Well, here's the issue. Okay, as I move across my period, my electronegativity increases, which tells you, well, duh, magnesium would have a higher electronegativity. But wait, magnesium is lower on the periodic table, which means that it would have a lower electronegativity. Well, higher and lower, we haven't done this yet. This is brand new, and I'm just introducing it now. Okay? If you are faced with this issue, because since magnesium is farther to the right, it should have a higher electronegativity, but it's also lower down, therefore to have a lower electronegativity. Okay? The direction that matters the most is which one is higher on the periodic table. Not moving across, but it's positioned vertically on the periodic table, because your number of principal energy levels matters the most. That's going to influence the size of your atom and therefore your electronegativity and your ionization energy the most. Alright? So in this case, since magnesium is farther down, that outrules the fact that it's farther to the right. Therefore, since it's lower down, it's going to have a lower electronegativity. Alright? So if I'm looking for the element that has a higher electronegativity, it would be lithium. Alright? And that is all the review of your trends.